So imagine at a point you compute one of these scale invariant functions like average intensity over a range of neighborhood sizes, okay? So we're at a single point and we're computing this function f over different region sizes. And you'll notice that, well, it goes down and then it goes up and then it goes down again. So that's my function that I've computed over different region sizes, all right? Now, let's suppose in my next picture I shrink the thing down by half. Well, now, as I compute that same function over the same region sizes, 2, 4, 8, 16, right? It's going to take the same shape, but it's going to get there faster, which is why this function is essentially just a squashed version of the one on the left. But it's the same function, just squashed. Ha. Well, what that means is, suppose we pick the maximum of that function. I'm going to call that S1 in image 1 on the left. And I take the same function, and I'm at some other point. I'm same function on point in the second image. If I were to take the maximum there, it would be a different size, right? Because that image had been squished in half. That would be S2. But these two neighborhood sizes would be covering the same region of the image between the two pictures. So they would be matching scales. So the important thing is, I do each one of these things independently. That is, I do this thing, and at this particular point, I find my maximum function, my maximum of the function. I say, that's the natural scale size that I'm going to use. Then I come over here, and I go to my other image, and I do over here, and I'm at some interest point. Remember, we found our interest points. And I look over all these different region sizes, and I say, aha, this is the scale there, and I compute that function. And magically, these two scales correspond. These are the same chunk of image. Here's a very nice illustration of that. Here's a picture of probably some beautiful church on the inside. Here it's just white and gray in some church in some mountainous area of Europe, I'm going to guess. And you'll notice that there's a function here that we're computing as a function of scale, and here it is. And this is the maximum point. And this circle is meant to reflect the scale size of that maximum. Here we have that same image zoomed way out, computing at this interest point. So we've got the same interest points. You notice that this interest point is just sitting at the top of this little chimney thing here. We compute the function again, and again we take the maximum, and that's going to be this circle. And the really cool thing is that this circle and this circle are the same components of the image. Those are the two scales to operate at. If we want to find descriptors that match, that's coming later. Basically, the scale of my detectors in one image should be big, and in the other image should be small. Also, the scale of my descriptors and my detectors.